Climate change has become one of the biggest challenges facing our planet today. These changes include rising temperatures, rising sea levels, and more extreme weather events such as severe storms and droughts. These changes are affecting the environment, the economy, and human health, endangering biodiversity and negatively impacting agriculture and water resources. Human activities such as burning fossil fuels, deforestation, and increasing greenhouse gas emissions are contributing to this problem. To address climate change, it is essential that each country takes joint action to reduce emissions, shift to renewable energy sources, and promote environmental awareness. The use of air conditioners that rely on electricity from burning fossil fuels contributes significantly to climate problems. The process of burning fossil fuels such as coal, oil, and gas to produce electricity helps release large amounts of greenhouse gases such as carbon dioxide into the atmosphere. These gases are responsible for intensifying the phenomenon of global warming. The increase in the use of air conditioners also leads to an increase in energy demand, which aggravates the problem of excessive consumption of energy generated from fossil fuels. Next Academy Online offers an innovative solution for cooling air using the temperature of seawater at a depth of 1,000 meters, which varies between 4 and 7 degrees Celsius. This solution is based on the principle of capitalizing on the low temperatures of the deep sea, being an effective method of cooling and reducing harmful emissions generated by traditional air conditioning systems. The idea is based on sucking hot and polluted air from buildings and institutions through a network of pipes, using a large turbine. The air, after being purified of pollution and carbon dioxide, is pumped through pipes to the seabed, where it is cooled by cold water, which has a temperature of up to 4 degrees Celsius. Then, the clean, cool air returns through pipes to homes and public and government institutions. This method not only helps cool the air, but also helps reduce environmental pollutants such as carbon dioxide. On the same principle, offshore platforms are being built to suck hot, carbon dioxide polluted air from the atmosphere. The idea is based on sucking in hot, polluted air through a large turbine, and the air, after being purified of pollution and carbon dioxide, is pumped through pipes to the seabed, where it is cooled by cold water at a temperature of 4 degrees Celsius. The clean, cold air is then returned through pipes to the atmosphere. Using solar energy to power the turbines in this method increases environmental sustainability and offers a complete solution based on renewable energy. Solar energy, due to its wide and free availability, is an ideal source for powering the turbines. These offshore platforms represent a promising innovation in combating global warming. They contribute to improving air quality and reducing the negative impacts of climate change. This innovation helps reduce carbon emissions and reduce the need for traditional air conditioners that rely on fossil fuels. Countries with abundant sunshine can benefit from solar energy to power offshore platforms and turbines. Solar energy is an ideal option in these regions because it is abundantly available and reduces dependence on traditional energy sources, such as fossil fuels, to operate these systems, thus promoting environmental sustainability. Air purification and carbon dioxide removal technology can become a source of income through the sale of reduced carbon. This technology can contribute to carbon offset projects, where carbon emission rights are sold or help reduce emissions. These rights can be sold to countries or large companies that need to improve their emission reduction quotas, thus providing an additional source of income. This technology could play a significant role in large carbon dioxide emitting countries, such as China, India, and the United States. It could be used to improve air quality in these regions by capturing carbon dioxide from the air before it is re-entered into the atmosphere. Improving public health. Reducing air pollutants helps reduce the incidence of respiratory diseases and improve overall health in large cities. Combating climate change. By reducing emissions, this technology can help reduce the impact of global warming in the most polluting countries. In conclusion, this technology can represent an important step in mitigating the effects of climate change and achieving a sustainable economic and ecological balance in sunny countries and major polluting countries.